Hello, let's let's prepare for the quiz on exact equations. And so I remind you what is going on. That they look normally something like this, right? You have two functions, the book calls them m and n, that depend on x and y, and they're written in the standard form this way. And so what this means is, what is an exact equation? That means that there is some f such that this guy, that will be the derivative with respect to x, and this would be the derivative with respect to y. That is, if the equation is exact, then there is an f for which this is true, that we can make this happen like that. And how do we know that it is exact? That is, if we take the derivative of m, let me use the notation. If I take the partial derivative, remember these are partial derivatives, right? If I take the partial derivative of m with respect to the other variable, that should be the same as taking the partial derivative of n with x. So this means that it is exact. It means that there is such an f that satisfies this thing. So what does this mean in this case? This would be, if it's exact, this would be the fx and this would be the fy. So the first step is it exact? We have to verify this, because otherwise it's not true that there is an f, so that the first one is fx and the second one is f of y. So what does this mean here? We have to take the partial derivative with respect to x of 2x minus 1, I say it wrong, right? This is what I have to verify. Let me box it here a little bit. This is what I have to verify. So in order to do that, I have to take the partial derivative with respect to y of the first guy, and I also have to take the partial derivative with respect to x of the second guy, x plus 2 times x minus 3, which, by the way, let's expand this, x squared minus x minus 6. If you don't see the expansion right away, just do it on a piece of paper, stop the video, do it on a piece of paper, and then come back. Okay, so what is the partial derivative here? So what is this? So here, let me write here the partial derivatives and then check that they are true. The partial derivative with y, what does that mean? It means that all this is just, as far as y is concerned, a constant. So if I take so in other words, I just have to take the derivative of this guy and copy that constant. So I get 2x minus 1 times the derivative of y minus 1 as a function in y. Well, that's just 1, of course. Here we have to take the partial derivative with x. Well, there is nothing else, so it is really just the regular derivative, so 2x minus 1. Are these two equal? So that's the question, right? Are they equal? And of course, yes, we see that they're equal. So we are exact. This condition is true. So what is then the step 2? Well, according to what we know, there's an f, so that if you take the partial derivative with f with respect to x, you get this. In other words, if you take the partial and the derivative with respect to x, you should get f. And the same here, if you take the partial and the derivative with respect to y, you should get f. Now, there are two things you could do. You can either work from this one, or you can work from that one. In this case, they're kind of both rather simple to enter derive, but I want to show you that actually this one is even the simpler. So pick one. Pick one. And we normally pick the first one, but just to show you that it doesn't have to, I'm saying that f is the partial derivative and the derivative, so I write it that way with the dy of fy. So this would be here, in this case, x, well, let's use the expanded form. Oh, dy. Now be careful, we are doing it with y, so all this is a constant. So this is x squared minus x minus 6. And what is the end derivative? Then this remains, right? It's a constant, so I take that out. So we get just x squared minus x minus 6 times y. But, plus in general, there's an integration constant here. What is going on is that as far as we are concerned, we keep x as a constant in this antiderivative problem, but for different x's we get different constants probably, so this becomes a function that only depends on x. If you, this is pick one, so this I picked the other one. If you don't like this and you say, professor, this is confusing me, let me just do it the usual way, you can do it too, right? You can do it this way, dx, and now what would it this time be? Well, y minus 1 is now a constant, and then I have to integrate this, which is x squared minus x, and then we would have a constant, but this time would depend on y, because we are antideriving. We're taking the antiderivative with respect to x, so this, as far as x is concerned, is a constant, because x thinks y is a constant. But different y's are different, might give different constants here, so that's why we get really a function, not just a real constant. So we have either this or that. Now I'm gonna not work out this case, because, but I just want to show you, you can do it too. Let's keep working with this case. What do you do the next? So step 3 is now, well, now you bring in the other one. So make sure that you don't mess up, right? So now, since I have done the partial derivative of y, I now bring in this case, so I'm going back to my original case, right? I'm back in this case. Well, I have to call f of x. And there are two ways. Well, so I'm looking at f of x, and I write it in the middle somehow. And at the one hand, what is f of x? Well, f of x is what we have here on the way on top, right? 2x minus 1 times y minus 1. That is where f of x was originally given to us. But we have a different way of calculating f of x because we know what f is. So we can also take it from here. So from here, so let me, okay, so in case that this blue guy is just the original coefficient of dx here. So what is this one? Well, now we take the derivatives with respect to x. So y is a constant, and then that is 2x minus 1. This is the derivative of this guy. And what did we do there? Well, we have a psi prime, derivative of that with respect to x. So we just write a prime here. So now we have two things that we have to compare. So actually, let's write this out. 2x, expand this here. And we see that there's some cancellation. Here everything could happen, but very often there's some nice things happen. Make it, well, no, sorry. There has to be cancellation, because all the y's have to disappear. Sorry, I forgot it. That's very important. I meant to say there might sometimes cancellation of x's, which doesn't happen here. But normally, well, no. If this works, if we are correct, then all the y's must disappear in this case, because psi is only depending on x. That is because we went the y route. If you go this route, if we go from here, what has to happen then after you work this out, you have to have something that only depends on y. So all the x terms have to cancel. But okay, so now we are there, right? So we see that, so if I expand this, let me go back in black. If I expand this, minus 2x plus 1 is psi prime. So psi is minus x squared plus x plus a constant. Well, we only need one solution. Because, be careful, because, so where are we now? Step 4, and this is very important. What is f? Okay, let's first time what f is, right? F, we know now what f is. F is x squared minus x minus 6y plus x minus x squared, this thing. But is that a solution? No, the solution is to put this equal to a constant. So the solution is that x squared minus x minus 6y plus x squared minus x minus x squared is a constant. That is the solution. So any c will give you a solution, because we know it's first order, so we have to have at least one constant, integration constant, right? And then we can, now step 5, we can look at, well, no, sorry. The next thing we need to do is, if possible, find an explicit solution. It's not always possible. I'll give you an example. or might be difficult. Find explicit. If I want explicit, I will tell you that I want an explicit solution. Okay. Now in this case, it's very simple, right? We have, in other words, i.e., solve for y. Okay. So solving for y should not be difficult, right? In this, we see x squared minus x minus 6. Y is, and I bring c plus x squared minus x. And now divide y is equal to x squared minus x plus c divided by x squared minus x minus 6. Okay? And then step 5, if there is an initial condition, then we look at it, and the initial condition was y1 is negative 1. y1 is negative 1. So you can plug this in. Where can we plug this in? Well, you can plug this in the final form, but sometimes it's quicker to plug it into the original, the explicit form, because then when you solve, you have to take denominators and sometimes radicals and stuff, so the function get more complicated. So I'm going to plug it in here. So what does this mean? So what is the interpretation of it is that if x is 1, then y is negative 1. So this is the two values that I plug in. So I plug in 1 here, I get 1 minus 6 times minus 1 plus 1 minus 1, x is 1, yeah, minus 1 equals c, right? C that I don't know yet. So let's work everything out. These ones, that cancels, minus 6. So I see c is 6. And I plug this in, and I find that my solution is x squared minus x plus c over x squared minus x minus plus 6 minus 6. Okay? I do want to do one more to show you that you cannot always have explicit here. This is a little bit bulkier, but okay, it's good to see all kind of things. X, y squared, I'm hoping that I will copy this correctly, plus 6x, this is the one that is in front of the x, that's the m, plus 2x squared y ex plus 2 dy equals 0, and I don't think there was an initial condition in this particular case. Okay, so again, let's see if exact, so this is the m, and this is the n, and if it's exact, this would be the partial derivative of this function f with respect to x, and this would be partial derivative of y. So step 1, we have to calculate that my is equal to nx. That's the question. Okay, so what's the partial derivative? Partial derivative with respect to y of this, of ex x squared y squared plus 2xy squared plus 6x. Well, let's do this now. Remember, ex is a constant. So I'll write it here to see that you see that's okay. So ex is a constant, and then we have to take derivative of this guy, but pretending the x squares are constant. So we get 2x squared y plus 4xy. Okay, what happens if I take derivative there? Well, that's 0, because x is a constant as far as y is concerned. Okay, that's the first one. Now we have to take the partial derivative with respect to x of the other guy, which is 2x squared y ex plus 2. Okay, if I take derivative of this, well, with respect to x, okay, yeah, right. So we have here a product rule now. Okay, y is the constant. So derivative of the first one, 2x squared y, let's take all these, this is the first factor, right? If I take derivative of that, that is just 4xy, and copy the second factor, plus now copy the first factor, and take derivative of the second factor. Okay, y is a constant, but we have it's product of two functions of x, and what the derivative of 2, of course, is 0. Now, are these two the same? So the question is, are they the same? And if a little inspection shows, yeah, they're actually the same. If you expand this, you see they come down to the same thing. So, exact. So, step 2, of course, if this fails, you should stop. Either you made a mistake, or you copied wrong, or the question is not, it's not an exact. I'm saying this also for later, because sometimes you're going to have to deal with different types, and you don't know in advance what type it is. So you want to check it's exact, but then you see, oh no, it's not exact, so it cannot work. But now that we have it, so let's now think what we should do. We have two options. We can think of f as the partial antiderivative of f of x. That was the first one, right? This was f of x, right? So this was f of x, and this was f of y. Or we can think of f as the partial antiderivative of fy dy. Why do I write both here? Because you always should see which is the easier to integrate. Is this easy to integrate with respect to x? I don't like that because of the ex. I think it's much easier to integrate with respect to y here because, look, there's only a single y here, okay? And so this is a major difference. If you, sorry, I'm pointing, I'm pointing in the wrong part. This one I was pointing here, but I should point here. But even here, this is much easier to interderive with respect to y. So although you have the choice, and sometimes it doesn't matter, and we prefer to take fx if it doesn't matter, sometimes it does really make a difference. And so that's what I want to point out here. So much easier. The other one is possible, but it is partial fractions, and a lot of you're gonna regret taking that one. So I'm gonna do the second one. So we're gonna take 2x squared ex y plus 2. Right now the y on the back because I'm thinking of the x's as constants, right? So f is an antiderivative, the partial antiderivative with respect to y. Okay, 2x squared ex is all constant, and then we have the antiderivative y squared over 2 plus 2y. But of course, there is going to be a constant, and that is now a function that depends on x. Make sure that you put here the right variable here. It's the other variable, right? Okay, so of course the 2's cancel, and so we have, now, what does this mean? Well, now we go to the other guy, right? We worked with y, we took the y root, and now we have to look at f of x. Okay, there are two ways of thinking of f of x. First of all, it is the given function, this guy, right? So I have to write this up. So it is, let me write it in black again. Ex x squared y squared plus 2xy squared plus 6x. On the other hand, it is the derivative of this function. Okay, there's a product rule, so I'm going to have to deal with the product here. Y squared is a constant, so I'll take that out, and then the derivative of x squared is 2x, and then copy the second factor, plus y squared x squared, copy the two factors, and take the derivative of ex, which is ex. What is the derivative of 2y? Well, y is a constant, so that's gone, plus psi prime. What has to happen now is the y's have to cancel. Is this happening? Let's see. Well, these two terms, if I combine them, let's combine them here, that's y squared, and then we have 2x ex plus x squared ex. Well, that's exactly what we have here, okay? The same way if I factor out y squared, you get the same thing. So this whole thing disappears, and we see that 6x is equal to psi prime, and therefore psi is equal to 3x squared plus a constant, but that doesn't matter because we need only one solution. So step 3 or whatever, I don't know anymore where I am. What is f? F is this guy, so that is x squared y squared ex plus 2y plus psi, which is 3x squared, and the solution therefore is x squared y squared ex plus 2y plus 3x squared equals a constant. Don't forget to write the solution. Don't just write f, it's the solution. And then the next step would be to try to find an explicit equation. Now this is not so easy anymore. If you can see why, because it's not just a single y, or y comes to higher powers here. There are still ways of doing that. You could use the quadratic formula pretending that x is constant, and then you get basically two branches of, because this in general y is a curve, right? It might not be the Grauwald function, it might be something like this. And in this case, it will be actually of two branches. So it will be a little bit like that. And you can write it down in the equations for both branches by using the quadratic formula with thinking of y as the variable. I'm not going to do that because that is not, it doesn't make it much easy, it doesn't make it easier or better. So in cases like this, one leaves it in this way. It doesn't mean that we still can, there's no initial value problem, but I can still do it. So let me, for simplicity, I have to be a little bit careful that I cannot take something in which the denominator vanishes, the dx vanishes. So I'm going to take, if x is 6, y is 0. Let's see what we get then. So oh, no, that's not great. No, because I don't want the ex. Let's do the other way around. And no, because see, I cannot take x equals 0 because then this would be 0. I guess I can. If x is 0, I'll put y equal to 4. Okay, let's plug it in. So that means 0 plus 8 plus 0 is c, and you see 8 is c. As I said, it's much easier to try to find a constant from this form because it's just plugging in. Whereas otherwise, if you have solved for the explicit equation, which we should try if we can, but if you cannot, then that's the best you can do. Okay?